You've built a solid on-prem PKI. Now we'll extend that trust into Azure. We'll compare ADCS, Azure Key Vault, and public CAs, then map them to Azure VMs, App Service, Application Gateway, and automation. The goal is to keep governance and security consistent, no matter where the workload runs. Up to now, you've built a full PKI skill set, from trust basics and lab design, through ADCS deployment, templates, enrollment, and recovery, into real troubleshooting with PowerShell and certutil, and finally hardening and governance. In this module, we'll apply that foundation to Azure and hybrid scenarios, where certificates secure modern cloud-connected workloads. Hybrid PKI is about choosing the right certificate source for each job, then making them all work together. ADCS continues to serve domain-joined devices, private TLS, RDP, and internal authentication. Azure Key Vault protects keys and certificates for Azure-native apps, VMs, and automation. Public CAs cover anything exposed to the internet that needs global trust. Across all three, you align trust chains, automate renewals, enforce access control, handle revocation, and monitor who owns and uses each certificate. Running ADCS on Azure VMs behaves much like on-prem, but you're adding cloud dependencies you must design for. Domain controllers, enterprise CAs, and web enrollment servers still rely on reliable DNS, Kerberos, and RPC connectivity back to Active Directory. Place CA and DC VMs in tightly controlled subnets with minimal exposure to other networks. Then treat these Azure workloads as full production systems, with strong hardening, regular patching, tested backups, and clearly defined security boundaries. For Azure-hosted ADCS, think end-to-end connectivity, not just the CA server. Every ADCS VM must use your domain DNS servers so domain joins, LDAP, and service location records work correctly. You also need reliable hybrid connectivity via VPN or ExpressRoute, so Azure CAs can reach domain controllers. Finally, verify that clients can resolve and reach enrollment URLs, CRL, and AIA locations, and that NSGs, routing, and Azure Firewall only permit required PKI and domain traffic. Consider ADCS availability in layers. Start by identifying what actually must be recoverable: the CA database, private keys, configuration, registry, and related AD objects. Then protect the VM with Azure Backup and add CA-aware backups using supported tools. Secure those backups and any recovery passwords so they're usable but tightly controlled. To finish, design for continuity with options like availability zones and, most importantly, regularly test full restores so issuing, CRL publishing, enrollment, and validation all keep working. Hosting ADCS in Azure doesn't make security easier. It just shifts the attack surface. Look at it in 4 domains. For identity, use privileged access workstations, just-in-time elevation, MFA, and strict least privilege. For hosts and keys, lockdown CA private keys, local admin access, VM extensions, and backups. On the network side, segment CAs, disable public RDP, and control flows with NSGs and firewalls. Finally, continuously monitor CA changes, template updates, Azure role assignments, and Key Vault permissions. Azure Key Vault gives you 3 related but different building blocks. Secrets are simple values, like passwords or connection strings. Keys are used for cryptographic operations, such as signing or encryption. Certificates bundle the certificate and its associated key with policy and lifecycle management, all tightly integrated with Azure workloads and identities. There are 2 main ways to get certificates into Azure Key Vault. One option is to import an existing certificate as a PFX, including the private key. You prepare the PFX, protect its password carefully, upload it, then assign access and bind it to your Azure workload. The other option is to let Key Vault create and manage certificates. A certificate policy defines subject names, key size and type, validity, and renewal or reuse behavior, often integrated with a public CA. Access control for Key Vault certificates comes down to 3 habits. Grant only the minimum actions each identity needs. Most users and apps just need get and list, while import, delete, and recover stay with tightly controlled admin roles. Separate responsibilities so certificate admins manage lifecycle, app owners consume certificates, and security teams review and approve. Then favor managed identities over static secrets and back everything with logging, alerts, and regular access reviews. Certificate lifecycle management is about never being surprised by an expiry. Configure alerts well before the date and drive changes through Key Vault's versioning model. Applications should either reference the latest version or a specific one, depending on your risk tolerance and rollback needs. Events from Key Vault can trigger event grid, logic apps, or runbooks to renew or import certificates, update workloads, and then validate that each dependent service is actually using the new certificate. Imagine an internal team publishing append.contoso.com on Azure App Service. For simple public sites, they might choose an app service, managed certificate, which handles issuance and renewal automatically. If security or compliance demands stricter control, they instead import a certificate or reference one from Key Vault, possibly issued by an external CA. For backend or hybrid scenarios, they rely on internal certificates and mutual TLS. In every case, automated renewal and binding checks help prevent unexpected HTTPS outages. At an application gateway, treat certificates as two separate problems: what the client sees and what the backend trusts. The gateway presents a certificate for TLS termination, ideally pulled and auto-rotated from Key Vault. When it talks to backend services, it validates their certificates, often against a private CA. Those backend certificates must match DNS and SANs, pass health probes, and fit your renewal plan, so the entire chain stays trusted end-to-end. Think of certificate delivery as different lanes on the same highway. Domain-joined VMs usually stay on the classic ADCS auto-enrollment lane, which is ideal for steady internal workloads. Non-domain or cloud-native systems rely on Key Vault plus deployment pipelines or agents. Automation and CI/CD should always authenticate with managed identities, never hard-coded secrets. Your governance defines which lanes are allowed, how certificates are named, who owns renewals, and how you'll rotate them quickly during incidents. You've now seen how solid ADCS fundamentals extend into Azure through deliberate networking, backup, security, and availability design. Azure Key Vault becomes a central trust anchor, while each Azure service has its own integration pattern. From here, document your architecture, test recovery end-to-end, monitor expirations, and assign clear certificate ownership so your hybrid PKI remains reliable and secure.